Today I'm going to talk a little bit more about exponential growth. If you haven't seen my part 1, you should go back and watch that. This will make a lot more sense after the first episode. So just to recap that first video, we learned that humans are not accustomed to comprehending how powerful exponential growth really is. We learned that when something is growing exponentially, it doubles in a certain time frame. And we learned that if the time a virus takes to double increases even a little, the growth can be decreased significantly. We used 2 hypothetical examples that seemed only slightly different, 3 days to double versus 6 days to double, to show that the respective totals at the end of a given time frame would be significantly different. So the new question is, what is the actual doubling time for COVID-19? My hypothesis was that the number of days it takes to double varies, but it seemed to be anywhere between 3 and 14 days. So how can we calculate the number of days that COVID-19 takes to double? So let's just review a little bit of what we talked about in my other video. If you have one infected person on day 1 and the virus doubles every 3 days, then after 30 days, during that 30-day time period, the virus would double 10 times because 30 divided by 3 is 10. And the result would be 2 to the 10th power, which equals 1024. Suppose we want to work backwards. Suppose we know that after 30 days we had 1024 confirmed cases. Suppose we don't know the doubling time and we want to figure out what it is. So we would set up an equation that looks like this. 2 to the 30 over x equals 1024, where x is the number of days the virus takes to double. So before we start solving that equation, we need to establish some mathematical properties. Think of it as our problem-solving toolbox. So the most important thing to understand is that mathematical operations have inverse operations. So addition and subtraction are inverse operations because they undo each other. If you have 5 and you add 2, then you take away 2, you're back to 5. Multiplication and division are also inverse operations, and exponents and logarithms are inverse operations. So I want to show you an example to demonstrate a very important property of logarithms. So we'll take this statement, 3 squared equals 9. We know that that's true already. And I want to show you that we can take the logarithm of both sides. So now we have logarithm of log 3 squared equals log 9. Now the property that I want to show you is that you can take the exponent, the 2, and bring it down in front of the logarithm so that it's multiplying by log 3. So now we have 2 times log 3 equals log 9. I want you to divide both sides by log 3, and now we have a new statement here. 2 equals log 9 divided by log 3. I want to show you that this is true. So you're going to put this into a scientific calculator, and if you can, try not to round this at all. When you're dealing with logarithms, rounding makes a big difference. So if you can do it without rounding, good. If not, just put in as many decimal places as you possibly can and check that this statement is true. So we were going to use this property of logarithms where we can bring the exponent down in front of the logarithm. That's going to help us solve for the variables which are in the exponent. So back to this equation. We want to solve for x, and right now x is in the exponent. So the inverse operation of exponents is a logarithm, so we'll take the logarithm of both sides. Then we'll use that property of logarithms that show that we can bring the exponent down in front of the log. So now we have 30 over x times log 2 equals log 1024. we're going to divide both sides of the equation by log 2 to isolate the variable on one side of the equation. So we have 30 over x equals log 1024 divided by log 2. We'll cross multiply. And then to isolate the x, we will divide both sides by log 1024. And we get x equals 30 log 2 divided by log 1024. And we find that x equals 3. 3 is the number of days the virus takes to double, and this is what we would expect since we already knew that 2 to the 30 over 3 equals 2 to the 10th power, which equals 1024. Now, using real data from Johns Hopkins University of Medicine, we find that New York, for example, in 49 days, the number of confirmed cases in New York grew from 1 to 238,831 cases. So we'd set up an equation that looks like this. We're going to take the log of both sides since the x is in the exponent. Then we'll use the property of logarithms to bring the 49 over x out in front of the log 2. Then we'll divide both sides by log 2. And here we're left with 49 over x equals log 238,831 divided by log 2. We're going to cross multiply, then divide by log 238,831 to both sides. We'll plug this into our calculator, and we will find that x equals 2.74. So the number of confirmed COVID-19 cases doubles in New York on average every 2.74 days, and that is so fast. So we can actually make a general equation to solve for the doubling time. You can take the number of days in a time period times by log 2 and then divide by the total number of cases. So in other areas of the world, we can use data. I live in Utah, so I wanted to naturally find out how quickly we're doubling there. So in 44 days, the number of confirmed cases has grown from 1 to 3,069. Using my quick formula on the previous slide, we can plug it in really quickly like this, and our calculator can help us find that it's 3.798. So in Utah, the number of COVID-19 cases has been doubling every 3.798 days. You can put that number back in for x to check that it's true. Again, it'll be a little off because of rounding. Try not to round as much as possible. So you can use that same equation to find the doubling time for other areas of the world. Southwest Utah doubles every 4.90 days. Sweden doubles every 5.78 days. The United States, on average, is doubling every 4.54 days. So remember, the growth will be exponential at first, and then it's going to change to a logistics curve. So the big question is, when will that happen? Statisticians are working to estimate that, and I have yet to find a consensus on their projected dates. So maybe that will be the topic of episode 3. Thanks for watching. Hope this helped you understand some of the numbers, and we'll see you next time.